Hello there, math fans. I thought I'd make a separate video on just a little bit of a unit circle speed test. So if you never realized the value of the unit circle, it can give you all of those things. I just made a whole bunch of random ones on the right in a matter of moments. So just by holding these up next to each other, we know what all of those values are. And if you know what you're doing, you can fill them in a few moments. So in a moment, I will do that, but I'm giving you time to think about it yourself. All the things you need to know is that the x coordinate is the cosine of whatever that angle is. The y coordinate is the sine of whatever that angle is. And then you need to remember the definition of the other functions in terms of sine and cosine. Tangent is sine over cosine, so I'll write it here. Hopefully by now, if I was doing it, I would already be done with all those. So you might just ask yourself, could you do that? This sort of highlights that if I was a student and I was given a note sheet, which we are in our classes, this is something I'd have on there because it makes it so fast. Or if I was a student and I was doing my homework, this would be sitting out if I was dealing with a section that had a lot of trig in it. So that's it. Everything we want is in there in terms of nice values. And the homework gives you quite a few nice values. Okay, so let's go. At this moment, you should be able to sit down and give the value. So I'm just going to say it as I do it. Cosine is the x-coordinate at 3 pi over 4. 3 pi over here, 4 is there, so it's negative square root of 2 over 2. Sine is the y-coordinate at 2 pi over 3, which is here, which is square root of 3 over 2. Tangent is sine over cosine at 5 pi over 6. 5 pi over 6 is this, so we're going to do sine, which is the y-coordinate, and we're going to divide by the x-coordinate. And we could write that as negative 1 over square root of 3 or root 3 over 3, several ways of doing it. Secant is 1 over cosine, so I'm looking for the x value at pi over 3, so it's 1 over 1/2, which is 2. Cosecant is 1 over sine. We're going to go to 7 pi over 6, which is here. We're talking about sine, so we're talking about the y-coordinate, but we're doing 1 over that, so that's negative 2. Cotangent, we're going to, at 3 pi over 4, we're going to go to 3 pi over 4. It's going to be cosine over sine, so that's going to be negative 1. Cosine of pi, hopefully now we're getting faster where we don't have to actually look. It's the x-coordinate right here. Sine of pi of 5 pi over 2, I threw that in as it's not on here. 3 pi over 2 is here. 5 pi over 2 would be back up at the top, actually. So we're actually here. Okay, arc cosine, those are also in there. Now, there's a little bit you have to know, which is when we do the inverse trig, there are many correct answers, but there's something called the principal domain. For cosine, it's 0 to 180. If you ever forget that, it's sort of the region that makes sense, because it always includes this, and then that's the next closest that has negatives. So you'd be looking here for when is the x-coordinate negative half. It's right here. What angle does that go with? It's 2 pi over 3. The principal domain for sine is not 0 to 180. It's negative pi to pi. So now we're looking here. This is when do we get negative? It's right there. That's at 7 pi over 4. Your calculator, I wasn't thinking about this, but your calculator would give you negative pi over 4 because it always gives you an answer between negative pi over 2 and pi over 2. Tangent is square root of 3. So this is slightly more work, but not really. We want sine over cosine to be square root of 3. So think about how that would happen. How would sine over cosine be square root of 3? It would have to be this divided by this. And so this is pi over 3. Again, if you have your unit circle, it's there. How is it possible for secant to be 2? Well, that would require cosine to be a half. When is cosine a half? It's right there. I didn't realize I gave several that were pi over 3 in a row. How is it possible that cosecant could be 2 over root 3? Well, that would mean sine would have to be square root of 3 over 2. Sine is square root of 3 over 2 there, so this is pi over 3. How is it possible that tangent can be root 3? A cotangent can be root 3. Well, that would require that cosine over sine is root 3. So cosine over sine. So this has to be pi over 6. And then I just threw in these other ones. At some point, you don't need to look over. That's why it's just good to do this from time to time if you never got this. So if you go to 3 pi over 4, I need the x-coordinate. It's negative root 2 over 2. If you go to 5 pi over 3, it's right here. I need the y-coordinate. It's negative root 3 over 2. I need the sine over cosine at 2 pi over 3, so it's square root of 3, so this is negative square root of 3. You know, WebAssign expects exact answers on everything we're integrating, so the way you finish the problems is you have your unit circle out if you're doing trig. All right, I hope that helps.